Hello. Here is an example of solving a 3x3 system that is a system of linear equations in 3 variables using Gaussian elimination. So remember, Gaussian elimination is when we put take the system and we write a corresponding augmented matrix, and then we use elementary row operations on the matrix until the matrix is in row echelon form. And just as a reminder, before we move on, what does row echelon form look like? Well, it's a matrix where, in this case, 3x3, it's actually 3 rows and 4 columns because it's augmented. So we look like this, where the main diagonal is 1s, the lower left-hand corner is 0, and then you can have anything you want in the other places. That's what row echelon form looks like. Once the matrix is in row echelon form, we then convert back to a system of equations and do a series of back substitutions to get the other variables, because as we know, once the matrix is in row echelon form, it tells us the value of one of the variables. All right, so let's do it. Okay, so first step always when doing this method is to write the corresponding matrix. All right, well, I might write the equations first, or the rows first, and then put the bracket, because sometimes I make it the wrong size. Okay, so first equation becomes the first row in our matrix. So it becomes -2, 3, -2, and then we augment with 3. All right, second equation, second row, 4, 2, -1, 9. All right, third equation, third row, 4, -8, 2, and -6. And the brackets. Okay. I don't like that bracket. Okay. Now there are many steps. This is definitely longer than the 2x2, but the idea is the same. And I always start in the same position. Right here, we want to start in the lower left-hand corner. That needs to be a 0. And again, you can't make it a 0 by multiplying the row by 0. That's illegal. You can only use one of the 3 elementary row operations. And so you can't make it a 0 by multiplying by a non-zero number. So you have to use the one where you can add multiples of any 2 rows to make a new row. So that means we need to have 2 rows that we can alter by multiplying by something, so that the corresponding position in our row has opposite coefficients, meaning the same number, 1 positive, 1 negative. So I'm already noticing that row 2, right? Row 2 has a 4 just like row 3 does. They are not opposite, so one of them is going to have to be made negative. Doesn't really matter which one. So I think I might do, now it doesn't matter, you could do -1 times row 2 plus row 3. I'm probably going to do row 2 plus -1 times row 3. And I'll tell you, the only reason I'm doing that is because in row 3, there are 2 semi-large numbers that are already negative, and multiplying that row by a negative number just makes them positive, which I like better, but it doesn't matter, right? If you had made -1 times row 2, then you would just add -2 to -8. You just have negative numbers. It really doesn't make a difference. I just, you know how I am with negatives. I drop them all the time. And so if I think it helps me reduce my errors a little bit. All right, so this is what I'm going to do. I'm going to take row 2 and add it to -1 times row 3, and that is going to replace, that's what this arrow means, row 3. So I'm going to actually do that work over here, writing it out. If I don't, I lose track of everything. Okay, so row 2, I'll do it in green. Here is row 2. I don't know why I didn't subscript it. I'm not doing anything to row 2, so I'm just going to copy it. 4, -8, 2, -6. Now I'm going to do -1 times row 3, which is going to give me -4, +8. Nope. Yes. wait, why did that's supposed to be row 2. I wrote row 3 where I meant to write row 2. Okay, let's rewind. That's what you gotta do. You gotta monitor yourself as you're doing this, because sometimes you just make simple errors like that. So I want to write row 2 first, which is 4, 2, -1, 9. And what I noticed was that if one was going to be 8, and I didn't think they were both 8. So, but you should pay attention, because with these 3x3 systems, I do tend to make errors. So if you notice that I make an error, don't think that you're necessarily misunderstanding, right? If you think it's an error, it probably is, and hopefully I'll catch it. Since it's a video, you can't tell me, but. All right, so I got row 2, that's actually row 2, yes. And now row 3 is going to be the same row 3, except all the numbers are going to be the opposite sign. I need more room. -1 times row 3. Okay, so 4 times -1 is -4. -8 times -1 is 8. 2 times -1 is -2, and -6 times -1 is 6. Okay, then we're going to add these two together. 0, that's what we wanted. That's a 10. That's a -3, and 9 plus 6 is 15. Right? Right. Okay. So now this becomes our new row 3. So let's scroll up here. We're going to make a new matrix. The first 2 rows have not changed, so I'm just going to rewrite them. We get -2 and 3 and -2 and 3. Second row stays 4, 2, -1, 9. And the third row is now 0, 10, -3, 15. Okay. Yes, and this video is going to be kind of long because it's just a lot of work. But it's just this one system. Okay, now what do we need to do? We got a 0 there, that's great. The other 2 places we need zeros are right here. So I would definitely recommend that you start with this position. Don't do this one first. Because it just makes it harder, because if you do that one first and then you have to do the other one, and depending on the equations you use, you have to be careful that when you add them together, you don't negate a 0 you already have there. So for me personally, I like to start here and make this position 0 first, then go do this position, and then go do this position. That's what I like to do. Okay, so we're looking to make this a 0. We obviously can't use row 3 because there's already a 0 there. And if we multiply row 3 by any other number, we're still going to have 0 in that position. So we're going to use the other row. It's nice that I see that row 2 has a number that you can multiply by 2 to get 4. So that's nice. They already have opposite signs. All right, so we're great. I think that's what we need to do. We need to do row 1 times 2 and add that to row 2. So let's write that down. I'm going to do 2 times row 1. And now just to verify what's going to happen, why are we doing that? Well, because this position right here is then going to be -4. So when we add those 2 rows together after multiplying the first row by 2, we get a 0 in the position we want. Okay. So we're going to do 2 times row 1, and we're going to add that to row 2. And that is going to become our new row 2. Okay, let's do this one in blue. So I write down 2 times row 1. So -2 times 2 is -4. 2 times 3 is 6. 2 times -2 is -4. And 2 times 3 is 6. Oh, that's interesting. I hadn't noticed the pattern there before. If you're wondering why I'm doing it so slowly and saying it out loud, 2 times every number, is because I have learned for myself that if I don't, I make simple mistakes, because there's so many little steps and you're multiplying so many different little numbers. Negative signs drop. 2 times 3 becomes 5. Things happen if I don't really go slow. And I would rather take it a little slower now than get to the very end after doing all that work and then realize I have an error and have to go back and find it. And actually, it's easier to just go back and redo the whole problem than it is to try and go back and find one error. Sometimes it's easier to find the error if you can spot it quick, but so just bear with me. And then row 2 just stays row 2. So that's 4, 2, -1, and 9. And I'm going to add those together. And again, -4 plus 4 is 0. That's what we want. 6 plus 2 is 8. -4 plus -1 is -5. And 6 plus 9 is 15. Okay, that is our new row 2. All right, so now I'm going to scroll up and I'm going to write a new matrix. The first row has not changed again, so it's -2, 3, -2, 3. But now the second row is that row we just figured out. So 0, 8, -5, 15. And now the third row, it hasn't changed from the previous step. So it's 0, 10, -3, 15. All right, we are getting there. Now the other position that needs to be 0 is this guy right here. I don't know, I did circle, then square, then triangle, just for fun. Okay, so notice this is one of those times where I definitely don't want to use row 1 to get to change that 10, because if I do, whatever is in this position is going to get added to this 0, and that's going to undo the work I did to make that a 0. So if you've done it in this order, you're always going to use row 2 and row 3 to do this last 0. All right, so this one I'm going to have to multiply both rows by something, because 10 is not a multiple of 8. Let's see, 8 and 10. I could do 80. I could multiply row 2 by 10 and row 3 by 8 and have 80, but you can actually do a smaller number because 8 and 10 already have 2 in common. So you could do, what could you do? 40. So I could multiply row 2 by -5. Now you can't see all of my things happening in my brain, but just bear with me here. If I do -5 times row 2 and 4 times row 3, right? That's going to give me, just look real quick, that's going to give me a -40 right here and a +40 right here. And that's what I want. Okay. So just don't need to have that there, but that's how I know I'm going to do that. What I'm doing is going to do something good for me. Oops. Then I want to use that to replace row 3. All right, so let's write this down. What did I do before? Oh, you green and then blue. Maybe I'll do green again. All right, so I'm going to write the work down for this. So I'm going to do -5 times row 2. All right, -5 times 0 is 0. -5 times 8 is -40. -5 times -5 is +25. And -5 times 15, what is that? Is that 75? I don't even, yeah. And it's -75 because -5 times +15 is -75. Okay. Then I'm going to do 4 times row 3. 4 times 0 is 0. 4 times 10 is 40. 4 times -3 is -12. And 4 times 15 is 60. All right, now we're going to add these together. 0 plus 0 is 0. -40 plus 40 is a 0. 25 minus 12. 5 minus 2 is 3. 2 minus 1 is 1. 13. Okay, and -75 plus 60, well, that's -75. That's the opposite of the number that's 75 minus 60, which is 15. Okay, and that's going to become our new row 3. Nice. Okay. Let's write it down. Okay, row 1 has not changed. -2, 3, -2, 3. Row 2 has not changed. 0, 8, -5, 15. But row 3 is now 0, 0, 13, -15. All right. We are nearing the end of our row echelon form. What we need to do now is make all of these 1. Now, you don't have to do any more of what we just did. No more multiplying and adding. Now you can just make them one by dividing by a number. So for instance, we want to put a 1 here, we have to divide by 13. We have to divide that row by 13. We want to put a 1 here, we have to divide that row by 8. We want to put a 1 here, we have to divide that row by -2. Yes, it's true, we're going to have fractions, but fractions are perfectly good numbers, right? They deserve love too. So let's just do it. I might write, here, hold on. I just want a little bit more room here. Bring it down just a tad, okay. So I'm going to multiply row 1 by -1/2. Now, why am I writing it as multiply by -1/2 as opposed to divide by -2? The real reason is because the elementary row operation is described in terms of multiplication, right? It says you can add a multiple of one row to another. That's one of the things you can do, or you can multiply a row by a non-zero constant. So because it's described that way, I like to write it as multiplication. But we all know that multiplying by 1/2 is the same as dividing by 2. Okay? So I'm going to multiply row 1 by -1/2, and that's going to replace row 1. I'm just going to write all 3 down right now, right? I'm going to multiply 1/8 by row 2, and that's going to give me a new row 2. And I'm going to multiply row 3 by 1/13, and that's going to give me a new row 3. And that'll give me a matrix in row echelon form. All right, so let's see. -2 times -1/2. I might say it in terms of division because it's easier to think about. So you get -2 divided by -2 is 1. 3 divided by -2 is -3/2. And -2 divided by -2 is 1. Nice. Don't forget the constants. You also have to multiply them by the same number. So that's going to give also -3/2. All right, now row 2, the 0 doesn't change because 0 times anything is 0. 8 divided by 8 is 1. -5 divided by 8 is -5/8. And 15 divided by 8 is 15/8. Nothing wrong with those numbers. They're perfectly fine. Row 3, 0 divided by 13 is 0. 0 divided by 13 is 0. And 13 divided by 13 is 1. And -15 divided by 13 is -15/13. See, I almost wrote thirds. That would have been definitely an error that I might not have caught until later. All right, we are in row echelon form. We've got the diagonal is all 1s, and the lower left-hand corner is all 0s. Okay, now is the time to convert back to a system of equations. So undo the matrix thing. So I'm going to write it below here. So the first row now corresponds to the equation x minus 3/2 y plus z equals -3/2. Well, I can see one solution to that equation by itself right now, but oh well. Okay, second equation, there's going to be no x in it because that first entry is a 0, so that means it's 0x was just a 0. So we're going to get y minus 5/8 z equals 15/8. And the third row has no x or y and says z equals -15/13. So yes, I kind of chose this example because the numbers were not pretty, right? They weren't just, all 2s and 5s and, 7s and 1s. But we are in a good position here because we already know one of the solutions, one coordinate of the solution here. Remember, the solution to a 3x3 system is an ordered triple. All right, it's an ordered triple that looks like x, y, z. And we know now that the z is -15/13. All right, and we're going to take that value for z and plug it into the equation above it, which only has a y and a z in it, and that'll give us y. All right, let's do it. I'm going to do it in green. Okay, so we're going to get y minus 5/8 times z, which we know is -15/13. And that has to equal 15/8. Man, isn't this lovely? All right, so that's going to give y plus whatever 5 times 15. I'm really thinking I'm just going to leave it like this for time, because you can't, nothing in here can be reduced. There's no factors that are the same on top and bottom. Notice here that minus a negative makes the plus, so that I might just leave it like this instead of multiplying 5 times 15 and 8 times 13, because I know I'm going to have to add it to 15 eighths, and so leaving it with a 13 visible will make it easy. Watch, I'll show you. Oops, don't want to write with red. So that has to be equal to 15 eighths, which means that y is equal to 15 eighths minus 5 eighths times 15 thirteenths. It's even, well, that's kind of magic. I was going to say maybe even my open math would take that, but I don't want to do that. So now we need a common denominator. And now you can see the reason why I wanted to leave it like this is because I can see that the left-hand fraction has an 8 in the denominator. The right-hand fraction already has an 8 and a 13. So a 13 this one needs a 13. So what does that mean? That means I can, what would I just do? If I multiply this guy by 13 over 13, then I have two fractions whose denominators are 8 times 13. What is 8 times 13? 104. Okay. So that's going to be, we have 104 here. Oops, why did I put plus? See, there's another thing where I would have made an error. Wait, it's supposed to be plus. No, it's supposed to be minus. Minus 104. All right. And on the equation, the fraction on the left, the numerator is 15 times 13, which is 195. And the numerator on the right is 5 times 15, which is 75. Okay. Which means then y is 195 minus 75, which is 120 over 104. Okay, I'm going to redo the y here. I just didn't write it here because I was being lazy. All right, now this can clearly be simplified because they're both even at least. So half of 120 is 60 and half of 104 is 52. They're still both even, so that's 30. What's half of 52? 26. 26 cards in a, and that's 15 thirteenths. Well, looky there. Really? I think that's true. That number was shown up before. I'm just using my calculator here to double check that that is actually 15 thirteenths, yes. Oh, so that's not the same as z, but almost, right? Z was negative 15 thirteenths. Y is positive 15 thirteenths. Okay, so this guy is y. So now we have y and z, and we need x. So scroll back here. We got to plug those two numbers. I'm going to write it down here. We just figured out that not z, y was positive 15 thirteenths. So now we're going to use both the z and the y to plug in up here, and we can solve for x. All right, let me see. Maybe I can start writing it right here. Go away. Maybe I'll do it with dark blue, just because I won't be able to see it if I scroll all the way down. So we're going to use x minus 3/2 times y, which we know is 15 thirteenths. I'm going to put it in parentheses just because I want to. Plus z, which we know is negative 15 thirteenths. And that should equal negative 3/2. All right, now we just have to simplify all this and we'll have our x. Nothing to simplify there. You know, if we really wanted to, we could make everything have the common denominator now. Because see how this one has a 2 and a 13. This one only has a 13. This one only has a 2. So we could actually do the multiplication first to get the common denominator and then solve. You know, why not do that, right? But you don't have to. Maybe I'll just multiply it this time because 2 times 13 is 26. That's pretty easy. So I just might do it. So this is, oh, I don't want to write in red. Blue. So x minus, this is 26 and 3 times 15 is 45, right? Yes. Plus Negative 15 over 13 equals negative 3/2. I just kind of want to add these together before I try and move it over. And so I can do that easily by multiplying this fraction by 2 over 2, because that gives me the 26 on the bottom, which is what I need to add two fractions together. Oh, I'm going to run into myself here. So x minus 45 over 26 plus negative 30 over 26. Just like to write the whole equation. You know, don't be lazy. I'm going to move myself over here because I'm going to run out of room. So I'm just going to kind of come slanty to write it down here. So x, missed my mark. So negative 45 over 26 plus negative 30 over 26 is going to give me negative, I know the bottom's 26, 75. All right, which means x is going to be, I have to add the 75 26 over there. So 75 26 minus 3/2. All right, which means if I multiply this one by 13 over 13, I get a fraction with a denominator of 26 and a numerator of 39, which is whatever 75 minus 39 is. And it is 36. Now, if I've made an error, hopefully you've noticed it. Let's see, if we reduce this, let my calculator do this one for me. I'm kind of tired of reducing. 18/13. And that's just 2 goes into both of them and you're done. All right, so that is your x. That's it right there. So let's see, can I write it right here? The solution is the x was 18/13. The y was 15/13. And the z was negative 15/13, if you remember. Ooh, isn't that a lovely solution? So let me see if I can kind of just sort of scroll through from the beginning. Ooh, look at all this work we did. All right, so we started here with our system. We reminded ourselves what row echelon form looked like. And then we wrote our augmented matrix that corresponds to the system, did our elementary row operations until the matrix was in row echelon form. Then we undid the matrix thing and wrote a system again. And then we did back substitution, which took a lot of writing because all those lovely fractions, right? Yeah, that's a lot of work for some fractions. But that's because fractions are like that, right? They need a little extra love. And then we got our beautiful solution there. All right, so that is solving a system of 3 by 3 linear equations using Gaussian elimination.